I work for Nexicom. We're a New York-based and Dallas-based cloud provider. We specialize in call center and telephone services. I'm going to jump right into it because it's going to be hopefully more demo than slides, although I love slides. So to give you an idea of what it is that we will be seeing, so it's not in the vacuum. This is part of our environment. We use a lot of Asterisk for a variety of uses, from PBXs to dialers to conferencing to custom applications for our clients in our data centers. And we have a management platform, which is an operations system, which covers a variety of needs, including provisioning and monitoring and billing. And it also helps other systems like the fraud detection and prevention systems, which are peripheral. We will only be focusing today in the relation between our operations system and the Asterisk deployments. For that, I need to clarify, we use a node we call Nexanode, which is basically a Golang client server that we use to basically have our management system talk to all of our Asterisk systems to actually do all that we need to do, from configuring to security to, I don't know, changing passwords, most of what you can do with things like Puppet. But we also retrieve information from our Asterisk using it. So ELKs, I honestly don't like calling it ELK. I call it ELK. But the ELK stack, let's make it shorter maybe. Raise your hands, those who do know what the ELK stack is. Oh, okay, no, I was hoping it was more, okay. So I'm gonna make it really quick. So the ELK stack, which is actually changing to a different name now, for a reason we will see afterwards, is a stack built upon Elasticsearch and a series of tools around it that have helped it really lift off. Although Elasticsearch has been around for a long time, for the old guard, I'm pretty sure you know Lucene search engine. I remember that like over 10 years ago when we first installed a wiki system in our company, we worked with Lucene as a backend for searching full text. So it has grown and become Elasticsearch, which actually is kind of a fork. Logstash is kind of the asterisk of this entire stack because it acts like duct tape. It pretty much does a lot. It's been doing a lot, but some of the things that Logstash doesn't do as well as other parts that are now part of the stack. And so if you jump into this, you will find that some functionality that you will find in Logstash, you will find in other components, okay? Because you can run this only with these three if you wanted to. The last, Kibana, is an amazing tool, and I hope to show you a little bit of it in a real-world scenario, actually with live data, so we can play with it and see how awesome it is. And you'll see that one of the things that it does is it speeds up the process of whatever it is that you're doing with data. It really helps you work with live data and figure out things that otherwise you wouldn't think of, or it would take longer to do. And when I say it really accelerates, I'm talking about 10-minute periods. That's all it usually takes to play with it. So the stack now, it's a lot of things. But out of all of these components, the one that I'm most interested in, especially for Asterisk, is the beats component. That beautiful bee over there, it represents beats, and beats is an entire library based on the libbeat library. You can actually build your own bit. I'm going to talk about it a little bit after that, what the purpose of it is. but it's basically the part that is replacing the harvesting functions in Logstash. All of those who have, I mean, among the ones that did play with Logstash in the past, and when I say in the past, I mean a year and a half ago, right? Many of the problems you had are solved by the Beats library. Now, all of the other ones are part of the offering by Elastic, from monitoring to graph to shield to Marble, which is the one that is for monitoring and alerting, and those are in a different licensing system. You can get a free license for Marble for basic functionality, like you get, for instance, for the DPMA module for Asterisk. The same way you do that with Asterisk, you can get for Marble for the basic functionality. So at the end of the day, that's what I meant by, I really don't know what we can call these anymore. I don't think ELK is the proper name for it. So now they're saying basically that's the Elastic Stack. So ELK is past, Elastic is new. That's the way we should call it now. Out of the stack, the part that is very important where you're, at least for us, which we develop and we integrate a lot, are the clients. So the good thing about it is that there's an entire set of officially supported Elasticsearch clients. Now you might be thinking, why don't you have a Logstash client or a Kibana client? Well, you don't need it really. But because the Elasticsearch is the data storage for the entire solution. So usually you want to shape your flows into Elasticsearch, analyze them in a way that makes sense, find out what it is that you're interested in, and then write something on the side to query Elasticsearch regularly to make decisions based on the information that you discovered. The clients are, and the community around Elasticsearch is pretty awesome. Now, I'm going really fast because I want to get to the demos. How do we put it together? Or how did we put it together? So the line that we created basically was, well, okay, in Elasticsearch, we use components of the Beats library. We started with FileBeat and TopBeat, which are the ones that most of us are interested in, right? We want to monitor our cluster, so we want to know what happens, when we have a certain amount of calls with, the CPU across the cluster. It's no longer relevant for us to go, box by box. That's really doesn't cut it because we're basically supporting and maintaining an entire data center. So FileBeat and TopBeat really cover the bill. FileBeat for anything that goes into logs, that's why it's called FileBeat. And TopBeat it acts very similar to StatsD, right? The StatsD module that Asterisk has, which is way awesome. And so that's what happens with beats, but that's also, again, also another thing that I wanted to say is that there's a beat now in alpha that is very, very interesting, which is metrics beats. And this is exactly what is similar to StatsD. And metrics beats, it acts both as a beat with the basic metrics, and also it acts kind of a framework so you can build your own metrics on top of it, but you don't mess with the base. So that's really great because it's a framework that you can build your own metrics on top of and stay in version, right? You don't have to actually fork and do something crazy with it. That's really interesting. But actually you can do a lot only with FileBeat and TopBeat. What happens then is that you end up having a lot of beats running around, so your orchestration system is going to be part of this. In our case, that's Nextnode. In your case, might be Chef or Puppet or your breed of choice, right? One decision we made that was good, we made many that were wrong, but one decision we made that were good, and I strongly suggest you do the same if you have the resources, is the first time you want to start working with this, don't start with the, with the Google version, right? And there's nothing wrong about Google. We work with Google, we love it. But if you start with the Google version, you're going to start with the, this is my box that has Elasticsearch, and it's easy to spot because all of the configuration says localhost all over the place, right? And so, yeah, well, you're putting everything in a single box. It's going to help you learn, but the thing you will learn is going to be pretty much useless. Unless you want to work with Kibana only. If you want to play with Kibana only and learn how to use Kibana, which is basically an interface, then it's going to be okay because you will be working in a single box and playing with the data. But then when you want to move into a real scenario, you're going to have a lot of problems, especially with Elasticsearch, right? Because it's built to be a cluster. So the minimum size for it, at least for Elasticsearch, and those are the associations that I opened, which started closing because I didn't put a keep alive on them. So Elasticsearch requires at least a minimum of 3 nodes, right? We're not going to. I mean, you have questions about it later. We can go over them later on. But as a rule of thumb, Elasticsearch needs 3 nodes to have a minimum amount of replicas to be able to properly fail over in case one node goes down, right? If you have 2 nodes, this is very, I'm pretty sure most of you are aware of it, but if you have 2 nodes, you get in trouble because you get the split brain issue, and the 2 nodes that are left will start fighting for consensus, and they're going to become both masters, and there goes your data, right? So invest the extra time and the resources and set it up with a minimum of 3 Elasticsearch nodes. The same with Logstash. If you will be pumping in a lot of data, it makes no sense to have an entire cluster of Elasticsearch if your Logstash layer is weak. If you start pumping really a lot of data, then of course you'll start having problems where you see that you're missing pieces of information in Elasticsearch, and that basically means that you're dropping messages at the Logstash layer, and then it basically means that you need either whatever you like, Redis or Rabbit Message Queue or whatever queuing solution you like. That's another beauty of Logstash. It has input plugins for pretty much every queuing, or at least well-known queuing system there is. Another note regarding, well, let me move into the sessions that drop. We have one, nice. It's gone. Okay. Okay, so let me put at least the one that I was going to open right now, it's open. So, so let me close that a little bit. Okay. So, so Elasticsearch is I cannot see anything, obviously. Let me see that. I said obviously way too many times. I don't think it's obvious, sorry. So Elasticsearch is it's a different beast when it comes to backends. It's a fully REST API data storage. There's no way to, there's no CLI, there's no, for those of us who are very used to, especially me, MySQL, and I still love it, it's quite a shift, but you'll see that whenever you have to talk to Elasticsearch, basically you'll have to do so via HTTP requests. This is awful for us as people who come from Asterisk or MySQL, but it's great from the programming and integration side of it, right? Because it's awful for a person, but it's great for, let me get that. I hate this thing. Okay. Okay, so what I wanted to show you is a little bit more interesting. Oh, by the way, what I just showed you, and I'm going to keep it, I'm going to not release it. those are the nodes of this testing cluster, right? So you can see that you have the three, well, there's four, sorry. Those are four Elastic nodes, right? Those are four Elasticsearch servers. Now the fourth, we usually use the C to mean client. So that's one of the tricks that we'll come back to later when we take a look at what needs to be done when you have a lot of requests. Because you need to remember that, you need to know actually that Kibana acts as a client to produce these reports, these graphics, right? And it can also be used as a sort of a stats proxy for other applications, right? So when you're using it personally to dive into data, that's great. But when you start using it as a proxy for other applications that want to display those graphs, then all of a sudden you have a lot of servers trying to access that server, and you have problems with Elasticsearch. So I'm going to look into that. How time? Okay. Let me get these up. Okay. So let me. Okay. So this is really uncomfortable. Okay. So this is a typical wallboard generated by the information of real servers. These are very few of them, but the beauty of Kibana is that you can dive into your information and figure out what it is that you want to see, and then create these small graphs separately and then put them together into wallboards, and then you can share those wallboards, or you can even share each graph separately. So this is really hard to do. Let me see. Yeah, I need to take it because it's impossible. I can't see anything on that side. So what I wanted to show you was this. All I need to do was click discover, but it's really hard to see on that side. So this is what you see when you get all of the information coming from the servers. Now, this part is very important because it's actually what allows you to dive into your information, right? And that's what, hold on, yeah, that's what this slide was about. It was about exactly that. So on this side, what you have are basically the pieces of information that you can search on. Okay, it behaves pretty much like you would on a regular database table, right? This is called an index, right? Right now you see that this is the top bit index. So this is, you're going to see here CPU and memory and about the files, information about the file system. I'm going to try and keep that in my mind when we get to the point where I tell you what happens when you get too much data, which I know there's no such thing as too much data. And I could understand that for a bank or for another type of company, but in our infrastructure, we have limited resources, and too much data can be bad for us. So that's one of the things, the first things we've learned, at least on our case, is we shape the data. We look at what's coming, we analyze it, and then we start saying, all of this, we don't need it, we don't want it, okay? And if we want it later on, then so be it, because we are really a real-time organization, so we're not very interested in what happens, in what happened 3 weeks ago on the CPU usage of our servers. And some of these things are really system draining. The The other thing that's good about Kibana is that it uses, first of all, Kibana is just an interface to Elasticsearch, right? All it does, it doesn't even store the information of these graphs. All of this information is also in Elasticsearch, right? The only configuration that you have for Kibana is the connection to the Elasticsearch cluster, that's all. But I wanted to explain one thing that's very important, and it's all of these pieces of information, you can see that they're typed, right? There are only a few types in Elasticsearch, right? By default, everything is a text because Lucene was built as a full text search engine, so it's reasonable that that is the case. But for us, it's very important, obviously, to generate those graphs to have not only count things, but be able to summarize, to generate averages, and so on and so forth. Kibana uses the simplest querying language that Elasticsearch has, which is the Lucene query language, is the traditional one. And it behaves really nice because it's simple. All you need to put is in the search up there, you just put the name of the field, to call it like that, semicolon, then you put the string that you want to search, and you say and, or, not, and so on and so forth, and it filters this real-time information real-time, okay? So what's the use of this? Well, basically what you do with this is you figure out what it is that you want, and once you do that, you save it, right? And you save it as a search, and then you can use that search to visualize information. Let me load. Is time okay? I'm sorry, I don't know what the time is really. Come again? 13 minutes total. I have left? Oh. Whoa, okay. So I'm gonna, yeah, sorry. So, so this is a graph that it popped up a couple of days ago by playing just for this, diving into data. So we were, this comes from a search from CDRs, right? And you know, that was the last thing we put in here because CDRs are things that I really don't want to lose a record about. It's something that is not natural to a storage that might lose things in the process, right? So that's why we never really used it. And a couple of days ago, we started playing with it and said, what can we do with this? You know, it's, I don't know. Let's play with, app data. We have app data. And that was, what can we do with app data? And just with that field was beautiful because we put up data, right? And we aggregated by tenant, by client. That was all we did. It literally took us 2 minutes. And we hit play, and we see this. And I was like, what is that? And we realized what it was. Well, that big thing going up and down, it's a huge dialer. So, and we realized really soon that only by getting that information, we could figure out which were the services, the VoIP services, that our clients were using the most. And we went, whoa, okay, that's nice. And it really, this was a question that didn't pop up before. It just popped up because the information was there, and we started playing, and literally it was 5 minutes. Okay, it's not gonna take you 5 minutes to discover every gem, right, in the bot, I get that. But the ability to iterate really fast with this tool is what makes it so interesting. Making the funnel is a different story, right? Making it get there, it's a lot of work, I'll give you that. But once it's there, you get to play with it in real time, and that's something that is not that often, that's not common. So let me, so another thing that, that's by discovering things, right? Another thing that we did was we started working with an application that we have on Elasticsearch, which is a conferencing system. that basically scales out. It's a conference system written in Go with ARI, which has certain capabilities. And one of the things we wanted to see was if we have a thing that calls nodes. We build the conferences with different bridges, and these bridges we call nodes, and we limit the size of the bridges, and then we connect these bridges in between. So basically, it's like balloons that are all connected among them, right? That's very efficient, very, very efficient compared to ConfBridge, for instance. And so what we did is we started running tests, and we really wanted to know if the tests were behaving the way we thought they should. So all we did is all of the logging obviously is in JSON, and so all we did is we send it to Elasticsearch, and we grouped by node and the amount of participants per node, and we got really fast one graph. Let me get it. Let me load it for you. It was awesome because it even helped us find. It even helped us find a bug. Here it is. But I can share this because the zooming capabilities, I'm going to show it here. Okay, while I have it there, I'll show the zooming capability, which is really awesome. Let me see if I can. Yeah, I will be able to. Okay, that is beautiful. Like, when I say dive into information, you literally can, even in your own data and your own graphs, right? So in this case, what we have is, this is a small one, right? Yeah, it's a 250 people conference or something like that. And each of those lines are each node. So you can see in time where we were pumping using CP, we were pumping the conferencing server and sending the participants in, how each node would grow until a certain moment and then stop growing because it was near the limit. There's a function that says, you know, if within certain time you reach certain distance for the limit, just close that bridge and go into the other, because these are Go routines. These are parallel programming. So we basically do some sort of a statistic to prevent any of those for being overflowed. And so you can see each of the nodes growing in time, right, during the conference. And this was great, actually, because this is what we wanted to do. But it's one thing to program it, and another thing to actually see it. Let's see if I can get back here. Yeah. Okay. So. Okay, so regarding what I said before, which is very important and it's going to happen to all of those who start playing with this. The idea is to save you some pain. We could go through the configuration, everything that you will find on the internet, which is not going to make any difference for most of you. But what happens when data comes, right? So the first thing you do is, and this is the beauty of Kibana, you use Kibana. Because Kibana is actually showing you all of the information that you're getting, and you get to play with it. At the end of the day, trust me, it's going to be no more than a day. You'll figure out what it is that you need. The rest can, you can leave it alone. Don't load it. No need to. Okay. Another thing that you need to be very wary about is a tool that is, well, TopBit is beautiful, but the problem with TopBit is that if you don't monitor it, you won't realize that TopBit takes a lot of CPU. And right, you're trying to monitor I know everything has a cost, but you can manage that. okay? Use the capability that each of these tools have to be granular. And so first, load it up, play with it, figure out what it is that you need, and the moment you do that, go back and close that faucet. Make sure you do that, because what's going to happen is that the system is going to work for 20 hosts, 30 hosts. The moment you start loading up with 200, 300, you're going to start having problems either dropping things on the Logstash layer, which we will solve by adding Redis in front of it, or Rapid Message Queue, or you will start having problems with Elasticsearch, which you will solve easily by adding more nodes to the Elasticsearch. But then again, you're taking a lot of measures that you may not need to take. So that really is the thing. So we're up on time. Sorry about all the glitches. If there are any questions, sure.
So can you describe the components and the configurations? Where exactly would you touch the configuration in Asterisk? How is Asterisk sending the data to Elasticsearch?
Yeah.
Because it's pretty clear in the other part, like how you look at the data, but it's not very clear yet how.
Absolutely, sure. So, in Asterisk, you really don't have to do anything. All you need to do is you install, for instance, let's say you want to read the Asterisk logs, right? So all you need to do is you install a FileBit, right? If you're running a Debian system, apt-get install FileBit, and it's going to install it. It's basically like a probe, right? And then that's what you configure. You don't have to touch Asterisk. You configure FileBit, and you say, okay, I need you to read the logs that are located in this place, right? And that's all you need to do. Now, by default, what you're going to do, and we're going to tend to do, or if you Google it, that's what most of the configuration will show you, is you have this great capability to have FileBit load an entire directory. So what you're going to do, var log asterisk, beautiful, I'm sending everything. No, that's bad. That's really bad. Do it specifically. Like you want to send the CDRs, then the entire path until to master CSV, and then you send only that file, okay? Be very specific about what you send, because you're going to send a lot. And sending a lot is going to take a toll on your Asterisk server, it's going to take toll on the Logstash layer, and it's going to take toll on the Elasticsearch layer. But yeah, it's very simple to configure. As a matter of fact, these components, the beats, which are basically the harvesters, are the ones that are taking the information out of your host and send them out, are very, very easy to configure. Very easy. Logstash in itself is a different beast because it requires that you configure the input with a proper input plugin. For instance, if you want to send your CDRs, all you need in the Logstash layer is to have the CSV plugin installed, which is basically Logstash install CSV plugin, something like that. It's very simple to install the plugin, and that's pretty much it. Logstash does a lot in terms of aggregating to your logs. If you don't, if you build an application that doesn't need any typing or anything, then you can certainly send it straight into Elasticsearch. You can do that. Oh, beats, like B-E-A-T, beats. Yeah, it's the beats library.
You mentioned that you were watching your boxes and you were seeing what in Asterisk was using the most resources, what was using the most CPU. How do you measure that, and how do you measure that and know what process or what, be it the meet, be it the queues, etc. How do you quantify how much is that using in the CPU? And how do you know for how long it's using that resource on the box?
Okay. So the question is, how do we measure the CPU usage per process on a box and for how long and where it pegs or not, because, okay, I understand. The question is towards which process and avoid the average. I want to know. I want to see a peak too. Okay, yes, well, TopBit does that by default. If you install TopBit, it's going to show you each process. Now, that comes at a cost, right? It's going to even show you pretty much every indicator in the file system. That's the one, the file system section is the one that I would deactivate the sooner the better, because FileBit can take on a small system even up to 4 or 5% CPU. Only FileBit, if you do that. You're hammering the entire file system. So that's definitely not good. It's not the same to ask memory or even processes, but then the file system. So that's what we be careful about. But you can do that. You can definitely only enable the CPU probes for every process, and you'll have a beautiful graph where it's going to show. It's going to tell you the name of the process. Sorry, I didn't. Sorry.
In what you had above, you had for the different things, whether they were using a queue or they were using meet.me and stuff like that.
Oh, that's
what I meant. So how do you not process
I'm sorry.
as in Linux, but like for the individual applications that you use in Asterisk?
Understood. Okay, now I understood what you meant. Sorry. Okay. No. Okay. So what we were able to do so far is to cross-reference the applications with the total CPU. But unless Asterisk is able to provide us with how much CPU each of its own processes consumes, we can't. We can do that when we run different ARI applications, because they are basically separate applications, right? Using Asterisk on the side. But that would be awesome. That would be awesome to ask to the Digium guys, that they would be able to log that, because then that would be incredibly granular.
Okay, we need to wrap this up because they're going to want to start the closing ceremonies. Please remember to go into the website, go to the schedule software, and rate Gaston's.
I have one thing that I wanted to say, because I really wanted to say it. It's the around the bend thing. You're going to hear Matt Jordan, I hope he does, say that login is going to go into JSON format now, and that's beautiful, because you don't know the amount of work that's going to save you if you're going down this path. And I hope this is a spoiler. I really hope so.